Okay, so for question 3, easy to get confused with our x and our z axis. So I'm going to split this problem, not trying to do it in parallel, but do one axis and then do another axis. So the first thing is to split up the turning moment here into its components. So it's make a note of which way it's turning around. So it's coming around this way, and we've got 50 kilonewton meters in that sense. We've got 3, 4, 5 triangles, so we know that's going to in effect be split up in terms of a turning moment of 40, and because it's sort of turning around there, that'll be turning around that way of 30. So coming out of the page and then back into the page, out of the page, back into the page, out of the page, back into the page. So I will do the how much bending stress we've got at B. I think we'll start there. So actually no, at this point here. So what should I call that? I will call that stress, bending stress, and it's in the z-axis. Right. So the we are going to be using the contrafactual formula, engineers bending equations. So stress is my over I, although we don't know what y might be in this context. It's in this context it is z, so it is mz over I. The m is going to be going along this axis, so that's the 40. So things are bending, if you like. Can you see that? Things are bending like that way along this axis. And so that's the 40 that we want to use there. Then I can use my I equals breadth times depth to the power 3 divided by 12. So in this case the breadth is 300 millimeters, and the depth is going to be 200 millimeters. Power 3 divided by 12, and that is actually the notation for that would be YY. I think, or would it be XX? Not too sure actually now. Doesn't matter. Right. What am I doing? Actually, let's check what would the notation be. Got this going in the Z direction. So what's the Y here? Breadth. So it's this one here, XX. So it's named after the axis it's turning around. Yeah. So it is YY. Right. So that's all hunky-dory, and that will be 2 times 10 to the minus 4 meters to the power 4. Right, so I've got the I know the M, and now the Z. So the distance from here to here will be 100 millimeters. So that's going to be my Z. So the stress along the Z-axis, maximum amount of stress will be plus or minus the M, which will be 40, and that is kilonewtons, so times 10 to the 3. The Z distance will be 100 millimeters. And the IYY term will be 2 times 10 to the minus 4. And that works out to be a stress of 20 megapascals. So now I'm going to repeat all this. I could have done things in parallel, but best to sort of like separate them up. Repeat all this now for going around this component here. So in this case, IZZ, you could swap the notation around if you wanted to, but the breadth in this case is in effect 200. And the depth is 300. To the power 3 divided by 12 equals, and that's going to have a larger value of 4.5 times 10 to the minus 4 meters to the power 4. So that's that, and we'll call this stress along this y-axis, and we'll call that stress y. So our stress y term will be, so we're going around, we're looking at this axis here, so we're looking at this turning moment here, so we've got 30 times 10 to the 3. We've got to work out the distance from here to here, so that would be 150. And then divide it by the I value. We're using second moment of area value, 4.5 times 10 to the minus 4. Pull that on my calculator, and I get 10 megapascals. Okay, so here we have got something in compression. So I'm going to use minus number for compression. So we've got minus 20 there, and a plus 20 there. Here, we're going around, we're trying to compress this side. So we've got a minus 10 here and a plus 10 here. So now I need to look at my corners to work out how I'm going to combine my stresses. So A, I'm going to have 10 and 20 added together. So stress A will be 10 plus 20, so that equals 30 megapascals. What about stress at point B? Okay, so here we're going to have a minus 10 at that point, and then we're going to have a plus 20. So we're going to have 20 minus 10 equals 10 megapascals. So it's looking like this one here is the right answer. I got that all right, right? That's fine.